are totally live right now.
Now
And
it's
I,
live, yeah.
yeah. So
Finally.
hello everyone, and sorry for being approximately 8 minutes late here. We actually thought we were live, but we weren't live, and maybe you could think of that as a little bit of a test run or a dry run of some sorts. But welcome everyone. Mark, Akansha, how are you both doing today?
Good.
Doing great. Yeah.
Awesome. So today we're going to dive into the usage of security tokens, short-lived tokens, and how we can solve the problem of using personal access tokens and not be so reliant on just having that level of data or having a set of credentials that could be leaked at some point and effectively expose you to changes that affect production. And so we've got Mark today that's going to take us through the security token service with Open Unison and how that applies to, when we're using version control systems or source control like Git, and then how that also applies to GitOps systems like Argo CD and maybe even Flux CD. Akansha, do you have anything you'd like to add? And sorry for just stealing the intro there.
Oh, no worries. So people who have been following us for past few months, they know that we have come a long way on this security journey. Firstly, we started talking about the enterprise silos, and Mark even came here and showed us about how Open Unison is being used within enterprises, right? And then that was just the beginning. From there, we went on to talking about so many things. We talked about securing various dashboards like Yali, Certificate Manager, and more. We even got into the depth of authentication and authorization. So, as Marino mentioned, we just today, like we have also discussed about the security tokens over live streams and Twitter Spaces. And today we are going to go more in depth of it and discuss about the personal access tokens with Git, short-lived tokens, and more importantly, how Open Unison can be used to help with the STS. So, Mark, before we get deeper into this, would you like to give yourself intro to our audience once again and give us a brief overview of access tokens and how they are being used?
Thanks, Akansha. So my name is Mark Horshing, CTO at Tremolo Security. I've been doing identity management in one form or another for over 20 years. I've been involved in the Kubernetes world since 2015. You'll have to excuse the bit of a frog in my throat. I'm getting over a bit of a sore throat here. But let's go ahead and dive in.
Yeah,
I'm gonna go ahead.
before we
Oh,
do,
go
I just
ahead.
want to say a quick hello to Guillaume. Welcome to the stream. Hope you're doing well. I know we were working together a while back on some projects with someone named by the name of Adam, and it's interesting to see where that project went and where we are. So hello, Guillaume, and welcome to the conversation. If you have any questions, feel free to ask us. All right, I will pass it along to you. Go for it, Mark. Feel free to share.
All right, so I'm going to share my window.
And while we're at it, one thing that I also want to just quickly define are the things like the personal access token and what that's really used for. And when you think about it, it's kind of an alternative to an actual password because it's a string. It's a very long string that can be used to authenticate to an API for that matter. The problem is like having to remember something like an API key and then storing it, keeping it somewhere safe, and then reusing it is not very sustainable. And so the alternative, and I'd say the better alternative, is what Mark's going to show us today with Open Unison and a short-lived token.
Exactly. So we're going to be using Argo CD as our example. So I've got a Argo CD deployment right here, and I'm going to start with tokens before I dive into how the STSs work and why you want to have an STS. Let's start with what a token is and why you need to be very careful with it. So I'm going to grab, I think it's the Argo. No, it is. the Argo CD application controller, right? Make sure I've got the right one. Yes. Okay, cool. So this is the Argo CD application controller. So this is the thing that talks to your Git repos when you deploy Argo. It talks to your clusters. So we're going to be managing multiple clusters here from a single Argo CD, and we want to do it securely. So the first question is, what does that even mean, right? What does securely mean? What are tokens? Why are we even talking about this? So whenever we talk about an access token, something to remember that's really important is that tokens are what are called bearer tokens. They are very specific to your environment, but they're also like a ticket to an old-fashioned tickets to whatever your favorite sporting event is, right? You go to a baseball game, you buy a ticket from the box office, it's printed on a piece of paper, and if somebody snatches it out of your hand and runs into the turnstile with it, that's it, right? Like you've got no recourse. It's not bound to anything in particular. And that's the way personal access tokens work, whether you're talking about GitHub or GitLab, doesn't really matter. Really tokens from anything. So here, let's take a look at the Argo token. So every pod token. So every pod runs with this thing called a service account token. Now, yes, you can. I'm actually going to make this a little bit smaller. Maybe that'll make it a little. There we go. So there we've got everything. So this token is going to come to here is what's called a JSON web token. And I'm going to commit the cardinal sin of bearer tokens, where I'm going to drop it into a web browser. Never ever do this at home, kids. And the reason is that this token is completely self-contained. It's digitally signed. It's got information in it about you. But what's important is that there's no phone home necessarily on the token. Now, Kubernetes is a little bit different. We'll talk about that in a second. But for the most part, when you generate a JWT, when you generate some kind of access token, whether it's a JOT, whether it's a personal access token, they're called bearer tokens because the bearer is the one who gets in. So if you lose that token, was there there was a bug that got announced a couple of weeks ago? Was it a CSI bug? That was logging tokens accidentally. I'd have to go back. But it's very common to get these bugs where developers are accidentally leaking tokens or they're logging tokens. And so what you need to be careful of whenever you're dealing with tokens is making sure.
Are you referring to like the Azure CSI?
Maybe that was it. Yeah.
Okay. Yeah.
It's
okay.
It's pretty common. I mean, the Calico has had them. VMware has had them. It doesn't take much to lose a token. And so if we look at, this is the token that's generated by Kubernetes. We have an audience. So this is my server running in Civo. We have an issuer. And we have when it was created, this IAT. So it was created today at 10:59 GMT, and it's good until tomorrow, 10:59 GMT. So that means this token is good for a solid 24 hours. Imagine the havoc you could cause if you had a token that was highly permissioned for 24 hours, right? And so what you want to do is you want to have short-lived tokens. Now, you can configure pods in Kubernetes to give you tokens as short-lived as 10 minutes. But in this sense, yep.
So there is a question from Guillaume. The question is how to deal with invalidation if there is no phone home, sign off, or account deletion.
Well, so that's the great question, right? And the way that you handle that is short-lived tokens. I generally don't like to issue tokens for more than a minute, and we'll show that off here in a second. But in the case of Kubernetes, the way that it handles this scenario is, one, you can shorten it down to 10 minutes if you do a manual token request. The other thing that you can do is when you validate this token for Kubernetes specifically, and we'll show this as well, is Kubernetes will not validate a token issued to a pod that no longer exists. So we're going to show off how if you delete this Argo CD controller pod, the token will no longer be valid. So those are the ways that you handle that, that you mitigate that risk. But it is a risk, and that's why with any kind of bearer token, having a short-lived expiration is so important. And you can see here in the token where it actually does issue or include the name of the specific pod, and more importantly, the UID of the pod. So if I delete this token, somebody does what's called a subject access review. Token review is the API in Kubernetes. If this pod gets deleted, which we'll show in a minute, this token will no longer be valid. So that's the first thing when you're dealing with any kind of token is how long lived is it? How do I retrieve it? And then how quickly can I invalidate it? So that's why tokens are so dangerous. They're very flexible, but they're dangerous. So if we're talking about, for instance, the difference between a token and, say, a certificate, certificates, if you issue them correctly, the private key never leaves the hardware, right? You generate a certificate signing request, that gets signed, you get a certificate, and then that way there's nothing going over the wire that's secret. The problem, though, becomes what happens when you have to cross TLS termination points. You can't go between, if you've got a service that's sitting behind a reverse proxy that's a TLS termination endpoint, you can't use certificate authentication anymore because now you've lost that connection. So that's where you have to balance between the security impact of having to use tokens versus the value of being able to cross network boundaries and cross complex networks. So that's why in the cloud native world, you end up seeing a lot more tokens because it's just a lot easier from a networking standpoint to build a network that supports a bearer token than it is to support certificate authentication. You don't need that point-to-point connection.
Mark, I have one question.
Go for it.
Yeah, so my question is like if we delete a pod and the token assigned to it gets erased, right? So what if we want to have that token assigned to the pod that gets recreated? I want to know what's the security implication of that. For example, the old pod generates a token that's valid for 30 minutes and the pod gets deleted and recreated before that 30-minute token expires. So can I still use that token for the recreated pod?
So it's a great question. It depends on the way you validate the token. Because this is JSON web token, you can go back to the API server, get the OID discovery document, which has a public key in it, and run that public key against this token and say, hey, this token was properly signed by the private key that's paired with this public key. Then you would look at this expiration and say, oh, is it still valid? So if that's the only validation you do, then even though the pod has been deleted, the relying party, the thing that accepts the token, will allow this to continue to work. That's an anti-pattern, though, with Kubernetes, because you can go back and check by running what's called a token review. So when we're going to show this as part of our security token service in Open Unison, is configured to go back to Kubernetes and say, hey, here's my token, please do a review and tell me if it's valid. At which point Kubernetes will say, no, the pod doesn't exist anymore. This is no longer a valid token. You should not accept that. And we'll show that in a demo here in a minute.
There's another question from Guillaume around whether or not MTLS. Actually, hold on a second. There we go. Because I'm okay hiding my face. Could MTLS the bearer token?
Say that one again. Sorry, you dropped out.
Could MTLS replace bearer token?
The problem with MTLS, or the challenge you'll run into MTLS, is twofold. One, if the certificate is not generated properly, you lose a lot of the security benefits. So to properly generate an MTLS key pair, you need to generate the keys on hardware, only move the public component, so the certificate signing request and the public key. If you have something like a service mesh where that all happens for you automatically, great. But if you're using some kind of external tooling, or you're doing something where something generates the key for you and then you install it somewhere, you're losing a lot of the security benefits. So that's the first challenge. The second challenge with MTLS is network topology. You have to have a point-to-point connection between your client and your server. You can't have any TLS terminating endpoints in between what generates the handshake on the client side and what validates it on the server side. If you do, then you've got to transition to something else, right? So like if you're talking about a service mesh, so we're talking east-west, that's not that big of a deal because the distance between your TLS termination points is very, very small. It's from the pod to, it's from the sidecar or the ambient mesh to the running process. So it's very small. The likelihood that something's going to happen there is very, very low. However, if your TLS termination endpoint is, say, a reverse proxy that is sitting in front of your ingress controller, now you have a much greater distance in between where bad things can happen. So the reason why, especially in DevOps, I think you get a lot more bearer tokens than MTLS is the network topology is just a lot harder to design for north-south, being able to go across clusters and across services with MTLS versus with a bearer token. It doesn't matter how many network TLS termination endpoints you go through.
So my question to you, actually, as a follow-up to that, you mentioned something about the network reachability piece. What happens when you start doing cross-cluster stuff where you have multiple clusters, and in the lens of service mesh, the way this happens is you actually have to create a common trust boundary. So you have to have a common CA across all. So you have effectively every single component of every cluster, every single service in each cluster trusting everything else, almost like an end-to-end like mapping or relationship, I should really say, and then relationship of what's going on. How do you address that particular concern? And could maybe Open Unison do it better and address it differently?
So that's a great question. That's where we're leading to, is how do you cross those boundaries? How do you cross those, whether it's a cluster, a service, how do you cross those identity boundaries? And there are two ways that you can do it. The first way is what you just mentioned, some kind of global trust framework, right? So whether you're talking in service mesh, you've got a common CA so that everything trusts everything else. In the token world, or I guess the larger DevOps world, you've got the Spire project, right? Using the Spiffy specification, where you have this common identity provider that generates tokens for everything. So it generates tokens for your pods, it generates tokens for your services, it generates tokens for your clients. You have one system that's generating tokens for everything. And so that creates your global trust, but you're still establishing a global trust. And that's great for homogeneous environments that's an option for. That might not be an option, though, because let's say you are talking across clouds. Let's say you are talking across different systems or different services where you don't have the ability to integrate that centralized identity provider. So that's when you get into the idea of a security token service, where you say, okay, I've got this token that identifies me. I need a token that identifies me to that thing over there. So in this context, we're saying I have a token from Argo CD that's good for my cluster, the cluster that's running inside, or that Argo is running inside of. So here's a actual kind of layout of what my clusters look like. So here we have the control plane where Argo is. We want to be able to push some changes from our Git repository into our development cluster, which is running a different Kubernetes cluster. So there's no Spire here to be able to issue common tokens. If you're running in a cloud like EKS or AKS, you could rely on your cloud's IAM to generate identity and validate it. The kind of challenge with that then becomes, one, you're bound to the cloud, right? So you've now built a system that is bound to a single cloud in particular. And, clouds are like Kubernetes clusters and potato chips. You can't have just one. Pretty much every large enterprise out there has multiple clouds. So that's the first question. Then the second question becomes, well, what if I'm not running in a cloud? What if I'm running on-prem, or the cloud I'm working on doesn't provide a Kubernetes level IAM? So then you have to ask the question, how are you going to bridge that gap? So that's where the idea of a security token service comes in, where Argo says, all right, here's my identity. I have it issued to my control plane cluster. Open Unison, please give me an identity that I can use with my development cluster. And so the way that you would do that without an STS is you might go to the development cluster and generate a service account. That generates a service account token, but that token either doesn't have an expiration or it's got a very, very long expiration. And so if something leaks that token, you're now in a scenario where somebody has access to your development cluster, and your only recourse is to completely rekey the entire cluster or to delete the service account, try and recreate it, depending on how you generated that token. So that's bad. Like that's not something you want to do. And I'll say, like, this exists with MTLS as well, depending on how long-lived your certificates are, because Kubernetes doesn't know how to check a revocation. So at least half a dozen times a year, if you're looking at the SIGAUTH channel in Slack, you'll get someone who's like, hey, we lost our master certificate, and somebody got it that shouldn't have. Can we invalidate it? And the answer is no. Kubernetes has no idea how to do that. So ideally what you want to do is kind of going back to what are the risks when working with tokens is generate a short-lived token. So what we're going to do is we're going to show how Argo CD, when it wants to talk to this development cluster, is going to take its issued identity from Kubernetes, ask Open Unison, say, hey, Open Unison, can you give me this identity for this development cluster that I can use? Open Unison will then do a token review request against the control plane to make sure that that identity is still good. So back to Akansha's question of, well, how do you protect against an identity issued to a pod that no longer exists? That's how you go back to the API server and say, please validate this token for me.
Sorry.
Yep.
Oh, sorry to jump in. But I had one question which this is brought up in my mind. So, is it beneficial to store and reuse keys? If so, how should one go about storing these keys in a secure manner?
You should never. So ideally, you would never store a static key because it's just getting issued to you. Mm-hmm. So in this instance, we're not storing a static key. It's being projected into the token. Now, if you do have something static that you need to maintain, we've got HashiCorp Vault in the control plane, some kind of secrets management platform. And that has its own discussion. The very short thing I will say about it is your secret management platform is not about keeping secrets secure, which sounds a little counterproductive, but it's about making it easy to rotate, easy to track. But that's a whole other conversation. Mm-hmm. But ideally what you want is you want to not be using static credentials. You want credentials that are constantly being updated the way that a pod's credentials are updated. So like we were looking at this JSON web token from Argo earlier, and it expires tomorrow at around 10:59. If we logged in at 11:01, we would find that there's a new token that's been issued for another 24 hours. So that token's constantly being updated. Excuse me. If you were to update the Argo CD pods that's only running for 10 minutes, every 10 minutes, you would find that there's a new token being projected into the pod.
Okay.
So let's go ahead and show this in action. So what I'm going to do is I'm going to, show what's happening manually in Argo to make this all work, so we could see the different pieces, because there's a lot going on and it all just magically works. So I wanted to kind of show what the different pieces are and where things can break. So let's start with what we're going to do. So we are going to, here are the steps that's going to happen. So step one is Argo is going to take its identity, its token, and call a web service from OpenUnison. Say, hey, OpenUnison, give me a token for my development cluster. OpenUnison is going to take the token that we get from Argo and do a token review request down to the API server and say, hey, is this token still good? Is it still valid? Can I trust it? Now, assuming it's still good, the API server is going to respond yes. And then we're going to check the authorization and say, okay, is this a token that is allowed to call this service? Because if I have the ability to call any service I want without an authorization, anybody in the tenant could, in the cluster could generate a service account. So we want to make sure that it's only happening for the right pod. As an example, let's say somebody were to breach Argo CD. Let's say there was a bug or something, right? They were able to get into the Argo CD pod. They could not use the Argo CD interface pod token to call this service, because OpenUnison would say, wait a minute, you're the wrong kind of token. I'm not going to accept it, even though the token itself is perfectly valid. So you want to have that authorization step in. Once we've done all that, we're then going to generate a token. Now, what's important to note here is that our remote cluster is registered into OpenUnison. So OpenUnison is now the identity provider for that remote cluster. So OpenUnison can generate a JOT that remote cluster will trust. So in this instance, we're using Kubo IDC proxy to do that, because the clusters are all running on CEVO, and you can't do OIDC with clusters running on CEVO, which is true of most public clouds. Starting in 1.30, Kubernetes does support multiple issuers. So it'll be fun to see that kind of roll out. But until then, we're using Kubo IDC proxy to do impersonation into the API server. So Kubo IDC proxy is trusting our OpenUnison. So OpenUnison generates a JOT for 1 minute that is going to be trusted by our development cluster, at which point Argo will then use that token to talk to our downstream. Now, the mechanism that Argo is going to use to kick this process off is a plugin system for the Client Go SDK for Kubernetes called a credential plugin. So the nice thing about that is it's all transparent. Like, I didn't have to configure Argo. Like, there's no like Argo plugin that I had to give it. In fact, I'm going to show it to you. It's all bash scripts. So it's really amazing how flexible you can be with Kubernetes clients when they're built against the standard SDK. So let's start having fun. So we've got this token over here, right? And the first thing I'm going to do is show what it looks like to actually get a remote token. So we're going to use our Argo CD token to do that. So I'm going to stop sharing this window. I'm going to go back to StreamYard. And I'm going to figure out how to use StreamYard. There we go. Window and here. Share. Can you all see my screen?
Yep.
Okay, cool. So what we're going to do is I'm going to flip back over.
I'm wondering
here.
if you could maybe increase the font size just a little bit, just for our viewers. There we go.
Is that good? Okay,
yeah,
cool.
That should be better.
All right, so I'm going to come back here. Where did my gwt.io go? Here we go. So the first thing I'm going to do is I'm going to push our token into temp OU token. All right, and then make sure I don't have this or export to config make temp. So I don't have access to anything right now, right? I've got this empty configuration. There's nothing in there. So what I'm going to do is I'm going to create a kube control configuration file that is designed to work with this setup. And we'll walk through what each of these steps does. So the first thing I'm going to do is create a credential. So the credential inside of kube control. So this is where you might set up your OIDC configuration as an example. Here we're using an exec plugin, a credential plugin. So if I do cat kube config, might be a little easier to read. So this is the result of what this command did. And so instead of embedding a token directly into the configuration file, what it said was, okay, you're actually going to run a command to generate that config. And that command is going to take the host that the remote cluster is running under, the name of the remote cluster inside of Open Unison, and where you're storing your token to be able to access it. So this is the token for Argo CD. This is not the token that we're going to use on the remote cluster. And so the nice thing about that is you'll notice there's nothing secret there, right? This config doesn't have anything in it that's secret. You want to post this up on GitHub? Be my guest, right? Like there's nothing there to lose. So that's the first step. Our next step is building out the rest of our config. So now we have a full config, right? We've set up a cluster. This is our Kubo IDC proxy host. We've set up a context, and we've set the current context. So now if I want to do something, uh-oh, did I do this wrong? Dial, okay, nope, this is definitely not right. What'd I miss?
Right context, different context.
Yeah, it's maybe? Let's try that again. There we go. Okay, so what happened here, right? Like everything just magically worked, right? So what's actually happening here is I'm going to crank up some logging here. Excuse me. So kube control ran a plugin, a script that called Open Unison using Argo CD's token to get a token to then make its API calls. Right? So if we look at this token, if we look at what that looks like under the covers, let's see here. I think I had open. Here we go. So this is what that script did. And there's not a lot here, right? We got a token by using curl, using our Argo CD token to call this web service. Then we returned a bit of YAML out of our plugin, and that's what kube control uses to get the token and then use it moving forward. So we're using the machinery that Kubernetes has built in, right? We haven't done anything to, like, we're not using a custom kube control binary. We're not using a custom plugin from interacting with Kubernetes standpoint. This is all part of the way Kubernetes works. It's just we're using it to our advantage. Excuse me. And so let's go ahead and wanted to show off what's going on here. So we're going to do this. I think this is how this would work. Temp OU token. Oh, wait. That's what it is. There we go. This should work. Yes. So this is what that command line is doing. Okay. So this is the exact same thing. It's just I'm doing it manually on my local system. So we're just doing a curl command to this service saying what the target that we want is. And Open Unison is then doing the work of saying, all right, is this a valid token? Does this pod still exist? Mm-hmm. Generating this token here. So now I'm going to go ahead and take this token and drop it into jwt.io. So let me stop sharing and switch back over here. So I'm going to open up a new jwt.io window. So this is the token that gets generated by Open Unison. And you'll see that
it's screen anymore.
Oh, right.
Yeah.
There's StreamYard. Present. Share screen. Window. There we go. And then all right. So here's the JWT that we generated. Here's the important part, the payload. The issuer now is Open Unison. So if we come back here, this is the original token that Argo CD used. Our issuer was Kubernetes. Now our issuer is Open Unison. So we've transitioned from using a Kubernetes issued token to an Open Unison issued token. The audience is our remote cluster. This is the Kubo IDC proxy that's running. Whereas if we come back here, which is our Kubernetes token, the only one that should be accepting this token is the API server, right? And then finally, we've got our initiated, so 1214, that was a couple minutes ago. If we look at the expiration, 1215. So this is going to expire in a couple of minutes.
So it won't be useful. Okay, so if we just wait a couple of minutes, this token is useless at this point.
Exactly. And then finally, there's an identity, which is sub, and just Open Unison control plane, which in and of itself isn't all that spectacular. What's important to note here is that the token that we're giving Argo is not for the same identity that Argo has internally. So if we come back here, our service account name is the identity of Argo. So our remote cluster in this instance doesn't know who Argo is, right? Our remote cluster is relying on Open Unison to enforce that this is an identity that should be handed out. Now, that's not to say we had to do it that way. We did it because of simplicity for writing out writing out different authorization rules. But in theory, we could have said, know what, we're going to pass through the sub so that you have to have RBAC rules written in your cluster against Argo application controller instead of this identity here, which is Open Unison control plane. So that's something to think about again when you write your STS. You want to make sure that you have some strong authorizations in there as well. So now that kube control has a valid token, can go across the wire, calls Kubernetes, does whatever APIs it's going to do. Every single time it makes that API call, it's going back to Open Unison to get a fresh token. Now we can build some, smarts into this certificate and, or not certificate, into this plugin so that, it caches it and, but it's still a bearer token. So you want to be careful of that cache. So that you're not going back to Open Unison until you actually have to, because a minute to do an operation is still a long time, right? You can do a lot in a minute. But that's what's happening under the scenes. Now let's go back to Akansha's question where it comes to what happens when a token or when the pod associated with the token gets deleted. I'm going to go to my control plane. Let's go over to Argo. Excuse me. So application controller, right? Yep. So let's go ahead and delete this. So our pod has been deleted and it's being recreated. So what's important here is let's go ahead and go in. Cat var run secrets token. So let's grab the new token. And let's fire up a new jwt.io. Whoops. And that, kids, is why you don't handle bearer tokens manually. All right. So, so here's our new Argo CD application controller. And what I'll point you to is that the name of the pod has not changed, right? Because it's stateful set. So you've got consistent naming. So if we come over here, we'll see that it's Argo CD application controller. Argo CD application controller. So the name hasn't changed, but the UID has, because every pod gets a unique ID. So even though the name is consistent with the stateful set, the UID is different. The service account, the name changes. I actually don't know. Does the UID change? No, the UID doesn't change because the service account hasn't changed. Right? Now, here's the question. If we go back, what happens to trying to talk to Open Unison? Because our token is still good from a JOT perspective, right? It doesn't expire until tomorrow. So if I just validate the token against the certificate, it'll work. But if I submit a token review request, it'll fail. So let's go ahead and stop sharing. And let's share. Nope, not settings.
So why does that fail?
It will fail because the pod that it's associated with no longer exists. All right, so we're going to run the same curl command to get a token. And if everything works the way I think it should, because that token was associated with a dead pod, Open Unison will reject it. No token. And here, there's a 401 error. So now if I do k get nodes, I don't have a token. right? So kube control won't work. If I now want to be able to continue to do this, I need to get that new token into my plugin. So let's just bring it full circle here. Grab this token that works. Echo -n temp OU token. So now let's try this again. So if I run my curl command, I do in fact get a working token. I run kget nodes and it works. So as the tokens are being updated and expiring from Argo CD, the old tokens are no longer valid. So you've got this continuous update of identity information. So we're not storing a static API key anywhere. Follow me so far?
Mhm.
So that's what the pieces look like in general, but what does it actually look like when Argo goes to do it? Like, how do you get Argo to do it? In this instance, the way that works is kind of ingenious. Like, Argo did a really good job of setting this up. Let me share here.
There's also a question from Siddhant. His question is, I'm curious to understand how Open Unison is handling refresh tokens, how long or short-lived. We know it's 1 minute in terms of how long those tokens live, but in the sense of a refresh, what does that process look like?
That's a great question. So this particular process is not issuing a refresh token, because you're doing just a token exchange, right? We're taking a token we're taking Argo's identity, validating it, and then issuing a short-lived token for it. So there is no refresh. It's not like OpenID Connect, where you authenticate and then you get a token and a refresh token and you want to keep it updated. So for this particular process, there is no refresh token. However, it is a good question, because when we work with tokens internal for access, and we can actually show that off here a little bit. So I'm going to go ahead. Let's show how this works. So I'm going to go ahead and grab a token from my control plane.
Are you sharing? You're not sharing your screen anymore.
I am not yet, no. So let's start with this. So let's say I want to get a token for my control plane. So I'm just going to grab the tokens, and then I'm going to go to share. I'm going to stop sharing. And then I'm going to go back to my code window. So I'm going to go ahead and create a new shell. Got a new config, so kget nodes, nothing works, right? So now I have a context. Get nodes. So I'm right now interacting with my with my Kubernetes control plane cluster via OIDC. And to the refresh question, what's happening is if I do a cat kube config, there are a couple of different tokens in here. So this is the ID token. So this is the short-lived thing. And that's good for 1 minute. And you can see it's pretty big. And the reason why it's pretty big is that it's self-contained. It has all of the identity information that I might need to talk to the cluster, which means it has all the groups in it. And because this is a development setup and I'm constantly creating new namespaces and groups, it's gotten pretty large. Mm-hmm. Then you have this thing here called the refresh token, much smaller. This refresh token is opaque. It's not a JOT. It has absolutely no meaning. It's just random garbage. What's important about the refresh token is that it's one-time use only. And it's scoped for typically however long your idle timeout should be. So if you've got an idle timeout on your web applications for say 20 minutes, like if nobody does anything in the web app for 20 minutes, the session should end. That's about where you set your refresh token for. And what's important about the refresh token is it's not shared with Kubernetes. It's only shared between your identity provider, so Open Unison, and your client, my CLI here. So as I get new configuration, as the kube control configuration is used and my JOT expires, because it's only good for a minute, so it's constantly refreshing, you get a new refresh token from Open Unison. So if I do a kget nodes, and then let's do a cat on the kube config, there are some variances in here. This isn't the exact same token. Now, Open Unison does have a couple of features to deal with potential collisions. ClientGo SDK has a well-known bug that if you've got two processes that use OIDC working off of the same kubeconfig file, it doesn't lock properly. So what ends up happening is you get one process that tries to do a refresh. Second process tries to do a refresh a second later. That refresh token then gets invalidated, and so the session dies. And so Open Unison has a couple of different ways that we handle that. One is every time you ask for a new client session. So if I come back here to, let's stop sharing. And I go to share. So every time I refresh this screen to get a new token, the tokens actually change, right? You can see from the refresh token that's changing. So you can generate multiple kube control configuration files for the same session. So that's option one. Option two is you can actually configure Open Unison to have a grace period where you can say, you know what, for 10 seconds, just enough time for these processes to be in sync, we'll accept an old refresh token. So, depending on your risk tolerance and how you want to handle that, there are different ways that Open Unison can make that a lot easier for you. But we really focus on making sure that the tokens are short-lived. And then once you log out, and this is where the magic happens. So I'm going to go ahead and log out. And let's switch back over to... Well, first thing that happens is
terminal session dies. Yeah, go ahead.
Yeah, so if I go to my dashboard, it stops working, right? I got to log in, and then if I'm going to go over to, I go to share. So this will hopefully be broken. Yep. So my session's been deleted. I can't use it anymore. I'm now logged out. So that's how we handle the kind of that round trip for OIDC. But for the STS, that's not super necessary because we're doing an immediate token exchange. So there is no need to do a refresh.
Mm-hmm.
So now if we want to see how this kind of comes together in action, I'm going to share this again. Present. Share screen. Window. Let's come back here. So let's go ahead and log back into Open Unison. Not now. And let's go into GitLab. All right, so I have a Git project. And let's say I want to create a new namespace. Now there's a bunch of namespaces here, right? So let's just copy one. So let's go ahead and here we go. So we're going to create a new file, and we're going to call this test 25. Right? Not super important. But before we do that, let's go ahead and log into Argo CD, and you'll notice everything's integrated via SSO. So it's all, yeah, it's all tied together. It's just one seamless environment. Now we got a lot of stuff in here. And the important thing is these namespaces. So let's go ahead and do a commit. Oh, right. We got to give this a name. What did I call it? Test 25. .yaml.
Do you just keep incrementing the test numbers and then it becomes
Yeah,
test 26?
it's a really complex algorithm that I use. It's called +1. And I cannot tell you how many times I cannot remember what the last one was, so I just skipped 10. So we're going to give this about 30 seconds here to refresh. But what's going to happen is once it sees the refresh, going to go back to our control plane to show you what's going on. So inside of Argo CD, there are secrets. So each cluster has a secret inside of Argo CD. Now, in theory, this is where you would keep that service account token that we're not going to use. The really cool thing is that configuration that we showed, we can act before on how we installed kube control exec, we embedded it here. So even though it's a secret, there ain't nothing here to lose, right? This can be pushed into a Git. You can publish this to GitHub if you really wanted to, right? Because there's nothing here to lose. You know, we're going to call our control plane for this cluster using our service account token. And we're going to use that same remote token shell. This instead is now on the, this is running inside of Argo. It's not running inside of, it's not running inside of my laptop, but excuse me. But what's happening here is Argo is saying, okay, I'm going to run that same exec provider, which is going to exchange my token. And it's been more than 30 seconds, right? So if we look here, has it updated? So no, let's just, oh, wait, no, I think it just went. No, it didn't. So I'm getting bored. Did it not? Oh, yeah, there it is. Test 25. Resource not found. What didn't it like? Is there a problem with my file? Do I not know how to create a namespace in Kubernetes? Test 25. V1. What did I do wrong here? Because it clearly does not like. Let's see here. It says that it's synced. Let's go over to our control plane, Kubernetes dev. Let's go to our dev dashboard. Yeah, there it is. So I don't know what Argo's complaining about because it clearly synced. Yeah, there it is. Matt Mosley for demo. That's weird.
Could just be a bug.
Yeah, it could just be something weird going on
But
there. But
we see it on the other side, anyways.
yeah, you saw that got created inside of our dev cluster.
Right.
Um,
Yeah.
and so it was able to do that without any hard coded credentials. And so bring it back full circle to where we started this conversation about STSs and risk management and how do you cross those boundaries? And STS is a powerful way to do that because now everything is just issued credentials, right? It's issued identities. Nothing is hard coded. There is nothing to rotate because everything is rotating, right? The thing that went across the wire. So if we go back to our picture, the thing that went across the wire from here to here was only good for a minute. So now if there's a bug anywhere here, Argo CD has a bug that starts logging tokens, right? Kubo ADC has a bug that starts logging tokens. The network provider has a bug that starts logging tokens. Whatever, right? By the time unless somebody's like sitting there waiting for that token and ready to act immediately, by the time they get their hands on that token, it's already
Too
expired.
late. It's too late.
Exactly.
Yep. So let me ask you this, right? So we have GitHub and GitLab probably has an equivalent of personal access tokens. There have been a few companies that recently discussed their own, I guess, approach to STS. Have you had a chance to maybe dive into some of that, and do you have any thoughts? And have you had the opportunity to reflect on maybe things that might be good about it or not so good? Love to hear your thoughts around that.
Yeah, I mean, I think the big thing that you get when you look at something like an Open Unison versus a much more specialized tool is that Open Unison's STS model lets you do anything to anything, right? Because we're an identity provider, so we support GitHub, right? We support GitHub apps, we support GitLab, we support certificates. So let's say you wanted to do instead of a Kubernetes token to another Kubernetes token. Let's say you wanted to do, let's say you're using Cert Manager to generate certs for your pods, and you want to use that identity to talk to GitLab to get a GitLab token. Sure. You configure Open Unison to say, I'm going to validate the certificate. Instead of validating a token, I'm validating a certificate. And Open Unison does support CRLs. So we can go back to your certificate generation system and say, hey, is this thing still valid? Right? Validate the certificate, perform the authorization, and then generate a token from GitHub. And now you get that same flow, right? And you're using that same system where you are able to generate that short-lived token. So that's really the nice thing about the way Open Unison does it is you're not constrained to a very specific use case. You can use it across your entire infrastructure. As long as it's something that Open Unison knows how to talk to, it'll work. So like in the book, in Kubernetes Enterprise Guide, we use Active Directory as an example, right? Service accounts in Active Directory to be able to talk to Kubernetes. Yeah. Mm-hmm. Enable Kerberos. Yeah. And that one we're using passwords, but let's say you've got Kerberos enabled. Open User knows how to talk Kerberos. So you could have your service account use Kerberos and a key tab to talk to Open Unison to generate a token for Kubernetes and then log in and use Kubernetes that way. So there's a lot of flexibility in the way Open Unison does that.
That's really cool. But I also want to know, what are some of the other solutions that might exist out there, and what are some of those challenges or flaws that they have that may make them not so ideal?
So you've got on the pure identity side, you've got Dex and you've got Keycloak. Both have security token services. I think the challenge there is that they're kind of constrained to the way that there are standards around these things, but the standards aren't really well fleshed out outside of like they're really more designed for API to API communication. They're not really designed for DevOps infrastructure work. So they can be really constraining. So that's probably those larger issues, or those more constraining side. ChainGuard released Octo recently, and that's just really specific, right? That's OIDC to GitHub. So if that's the only thing you need to worry about, then great. But in a heterogeneous environment where you've got GitHub, you've got multiple clusters, now you're maintaining multiple systems, and that to me is just extra work, and that can get dangerous. So why not just have one system that does it for you for all of them?
I love it. I like the call out to Active Directory too, because that seems to be a very recurring theme across a lot of enterprise environments. And actually, yesterday I was at a meetup, the NADOG meetup, which was in Toronto. And one of the conversations that came up, I was actually talking about reliability, but we started talking about logins and actually login fatigue, and how SSO really helped with that dimension of like, so folks didn't have to remember so many different passwords and usernames and whatnot. But then it also came up, like the conversation around how token exchange came up as well, and how some of those identities, like in Active Directory, actually get translated into those short-lived tokens for a temporary basis or for some sort of authentication mechanism. So, to those that are actually watching this, right, if you're using Active Directory today too, that's a great starting point for being able to just take advantage of what Open Unison has to offer. But not only that, like it's not specific to Kubernetes either. If you're in the cloud space even, and you're really rethinking some of your identity access and management policies and approaches, Open Unison might be the way. So I think that's all you've got to show us, right, Mark?
Yeah, unless there's some questions, if folks want to see anything else.
I don't have any questions. I just want to say a quick hello to Ashwin. Thanks for coming by. Akansha, any thoughts or questions on your end?
No, like no questions, but like it's interesting to see like how different tokens were handled by Open Unison and all the things that engineers need to keep in mind, like when they are building their systems and everything. So that was nice. Thanks, Mark, for like showcasing your product and all the use cases which it offers.
Yeah, fantastic. Mark, any final thoughts before we close off for the day?
Short-lived tokens. Short-lived tokens. It's going to be on my tombstone. Short-lived tokens.
Short-lived tokens. It's the name of the game. All right.
Exactly.
Well, thank you very much.
I will also drop a plug if you're interested in seeing the code for the demo and how we built all that. It's all in GitHub. So Kubernetes and Enterprise Guide 3rd edition is going to be coming out, I think, in August, maybe September. I'm not sure if they've pushed it back yet, though. And that entire build out that I showed you is all included in the last chapter. So if that's something that you're interested in, how those pieces all fit together, go ahead and pre-order on Amazon.
Awesome. Could I, is there a GitHub that I can link? I think I found it, or I might have found it. Or is this the work in progress one?
Let's see here. It's going to be Packet. Hold on, I can grab it for you.
Yeah, I think I'm looking at the right one then.
It's this one here. Where'd Stream go? Send it to you.
Cool.
Yeah, that's the one.
Yeah. Awesome.
So that's got all the code for how we built it out with Pulumi. We use Pulumi as the IAC tool to build out the 3 clusters. It's running on Civo Cloud, but should work on anything. And then the book itself will actually talk through how all that integration works, because you've got a lot going on there. So grab the book and enjoy.
Fantastic. All right. Well, Mark, thank you so much for coming aboard this stream, for actually hopping on the Security Token Express, I should really say.
Exactly.
So we hope to do some more of these. We'll be reaching out, and we'll actually be announcing some more streams. We've got some to talk about Kiali and how we authenticate into Kiali with Open Unison. We're also going to revisit some of that pipeline security as well, and then also discuss the namespace as a service technology, because I think there's a lot to say about namespace as a service, and specifically like the approaches that we've seen over the years and how it's evolved into what we do today. So really looking forward to that. Mark, thank you again. Akansha, thank you for being a
Thank
gracious
you.
host and showing up here. So thank you all for joining today, and we'll see you all soon. Take care, everyone.
Thanks.
Bye.